And welcome back to another video. Today we'll be doing some questions about Archimedes principle. So let's get right into it. First question here says a block of wood with the dimensions 0.12 by 0.34 by 0.43 cubic meters float along a river with the broadest face down. The wood is submerged to a height of 0.053 meters. What's the mass of the piece of wood? Now, first thing we need to know is what volume of this wood is submerged underwater, so we know what volume of water is displaced. So it says the broadest face down, so it's gonna be the face with this side by this side. So firstly, we're gonna have 0.34 multiplied by 0.43. And then now we're trying to find a volume, so we're going to multiply it by the height that's underneath the river, and that's 0.053. So you're going to give us the total volume of the wood that is currently submerged while the wood is floating. And if we punch it into our calculators, we can get 0.00775 cubic meters. So now what we've just found, we found the volume of water that's displaced. Now we want to find the mass of that volume of water. Apply Archimedes principle. So we know that density, we'll use D for density this time, equals mass over volume. So mass is going to equal the density of water, which is 1000 kilograms per cubic meter, times the volume here, which is 0.00775 cubic meters. So of course cubic meters cancel out per cubic meters, leaving kilograms. And when you multiply this by 1000, we simply just move the decimal place, and we end up with mass equals 7.75 kilograms. So this is the mass of the water that's displaced. But this is also the mass of the piece of wood, because if the piece of wood is floating, that means that the downward force of gravity acting on the wood, which would be gravitational friction times its mass, is equivalent to the upthrust from the water. And as you know from Archimedes principle, the upthrust from the water is equal to the weight of the fluid displaced. Therefore, the mass of the fluid displaced in this case is also the mass of the wood. Move on. You turn the basketball beneath the surface of a swimming pool until half of the volume of the basketball is submerged. If the basketball has a radius of 12 centimeters, what is the buoyancy force on the ball due to water? Now, the first thing we do is convert centimeters to meters. Always use SI units. And so 12 centimeters would equal 0.12 meters. Okay. Now what we need to do is we need to find the volume of the entire basketball, then divided by half. The basketball is a sphere, so we use the formula 4/3 pi r cubed. That's 4/3 times 3.14 times 0.12 cubed. And with that, you can just go ahead and divide it by 2 at that moment, and we end up with 0.00362 cubic meters for half of the volume of the sphere. It says that half the volume of the basketball is submerged. Now all we need to find is we need to find the mass of water that is displaced. And since we just found the volume, all we need to do now is multiply it by density to find the mass. The density is 1000 kilograms per cubic meter. And so multiplying it by 1000, you would just move the decimal point. We end up with 3.662 kilograms of mass for the water displaced. But we don't want the mass of the water displaced, we want the weight. According to Archimedes principle, we want the weight to find the buoyancy force. So we would then multiply this by the gravitational field strength, 9.81, and we end up with 35.5 newtons of buoyant force. Third and final question. A 4,000 kilogram boat floats with one third of its volume submerged. If two more people get into the boat, each of whom weighs 690 newtons, what is the additional volume of water that's displaced? So here, we're going to have to add the extra weight of these two people and calculate the mass that they are. So we have 690 newtons for both people. So we just multiply 690 by 2, and we get 1380. So an extra 1380 newtons of force was added. Now we need to know what the extra mass that was added. So we would divide this 1380, which is the combined weight of the two persons, by the gravitational field strength 9.81 to obtain their mass. In doing this, we will get the value of 140.7 kilograms. So an extra 140.7 kilograms was added to this ship. Now we need to use the density equation and solve for volume. So if D is equal M over V, then V is equal to M over D. So the additional volume displaced equal to that additional mass, 140.7 kg all over 1000. And because it is just zeros, we can just move the decimal place and we end up with, we can put it in the calculator and we end up with 0.14 cubic meters. And that's all for today. See you next time.
pretty lies. Look me in the face, tell me that you love me, even if it's fake.